Okay, radical and exponents are related in that fractions as exponents can be written as radicals, and radicals can be written as fraction exponents. So if we look at our first example here, we have 25 to a fraction exponent. Well, a fraction exponent simply means the square root of that number. And if you press square root into your calculator, you'll get the answer to be 5. Now, if we look at this other problem, if it's already a square root, we can change that 18, and instead of writing it as a radical, we write it as an exponent, but it's not an exponent, it's a fraction exponent of 1/2. So square roots is the same thing as an exponent of a fraction, 1/2. Now in some special cases, we have what's called an nth root. That means if we have something besides a square root, in this case we have a 3, we would still write a radical, but instead of the denominator being a 2, it would be a 3. And so our fraction is 1/3. So if we look over here in the second problem, we have a 5. So I'm going to write my 32, but my fraction now is going to be 1/5. So that's how we write what's called nth root. So sometimes you have a cube root, a fifth root, or a square root. Now what we can do is we can solve these. Evaluate means solve. We can take our 125 and we can put it into a square root, 125. But it's not a square root, it's a cube root. And if you press that in your calculator, you will get the answer of 5. Same with this problem, we can do the fourth root of 1296. If you press that in your calculator, you will get 6. So we can get our answer by simplifying by just pressing the calculator. What we're going to do now is we're going to do exponents where it's not just a 1/3. So this becomes the cube root, because it's the 3, of 64. But when we get that answer, we're going to have to square it because that's what the 2 means. So the denominator is always our root. So now we want to find this answer, cube root of 64. So you press it in your calculator, you will get 4. So once we get that answer in the parentheses, we can then square it. So 4 squared will give us our 16. So let's look at our next problem over here. I want the cube root of 36. Oh, my fault, not cube root. I read that wrong. Square root of 36, but I'm going to cube it. So the denominator is always our root. So the denominator. So the square root of 36 is 6, and then we want to cube that. So that ends up being 216. The most difficult problems is when we have to solve. To solve these, we need to have the exponents, or the bases, be the same. Well, we have 6 to the x power, so 6 is the base. So I need to get 216 into a base of 6. That means I need to take 216, and how many times does 6 multiply to give you 216? Well, 6 times 6 times 6 is 216. So this is 6 cubed. So all we do is rewrite 216 as 6 cubed, because 6 times 6 times 6 equals 216. So it's 6 cubed. Once the base are the same, we make an equation with the exponent. So x equals 3. And so we've solved an exponent equation. So let's look at this next problem over here. I have 5 as a base. I can't break that down any further, but 25 can be squared. So I just make 25 as 5 squared, and I still have an exponent of x minus 1. Well, I have 2 exponents. Well, the power to a power means I multiply. So 2 times x minus 1 is 2x minus 2. That's just the distributor property. And that equals, well, what's exponents over here when there's not 1 written? It's a 1. So that equals 1. So now we come back to one of the fundamentals, solve an equation. So I add 2 to both sides, and so I get 3. And when I divide by 2, I get my answer is x equals 3/2. And so that's how I solved this equation.